Okay, it's Saturday morning and I just barely got here. Just set up the computer, got my coffee chest going there. I'll watch that in a second, but I just want to do this intro to this video. And today's little project is going to be grinding these lathe grooving inserts on my grinder with this special, I've made this special shank to hold this style of inserts. I have different ones I've made for different style of inserts, but this is this one, and what I've got to do is, I don't know if you can see this in the video clearly, but this is the detail. I've got to grind this insert to make that groove profile in the OD of some part that they're doing here. And so I'm going to go through I've already done this before, so I've already got a program, and I'm going to show you, go through the steps of how the program works and everything in this video, so you can kind of see what's happening with this kind of a job. Like I say, this grinder is mostly made to grind like tools like this, like end mills and rotary tools they call them. So it's not totally designed to do stuff like this, but you can kind of make it do it because you're in effect telling it it's got a single flute form tool. That's why I've got this in the round collet, and then you just grind one flute of the tool here is more or less what you're doing. I'll show you that in more detail in the control on the machine. So anyway, I'll watch my coffee chest first. I'm going to turn on the machine and get started here. Alright, here we are in the machine. I've turned the machine on, and I'm going to install this. This is the screw that holds the insert on. I'm going to put that right here right now. I'm going to install this shank in here. And I'm going to tip it down a little bit like this, so it's pointing down when I clamp it in the collet. Like that. Get an insert here. Now the reason is it's going to probe it, and I just want to make it easier for the probe to find it. This orientation doesn't matter at the moment because we're first going to probe the insert. So what I'm going to do right now is going to clamp one of the inserts in there. And I think I'm just going to run the probing cycle just so you can see it. Normally I wouldn't do this right now. I would do it when I'm actually getting ready to grind the insert, but I'm just going to do that first, just so you can kind of see what happens here. First I have to tell it the right wheel is in the spindle. I've already put the appropriate grinding wheel in here that we're going to use for this, but I didn't tell the machine's control that it was in there. Now we're going to just start things here. I really can't film anything in here when it's grinding itself because there's too much coolant. This machine uses oil for coolant, and it just makes a mess of any kind of camera you try to put in here. So I'm just going to have to I think I could show it grinding dry after it's ground one. I can't really grind dry with these kind of wheels. It'll mess up the grinding wheel, so I don't want to do that. So let's see here. I think it's ready. I can start the control here. And if I put everything in the right place, I don't know if I have here. Let's see. It should find the tool, touch off the length. It's going to lift up and come in far enough to catch the tip of that insert on the probe, like that. Now I'm going to stop it there for right now because I just want to show how it touches that off. All right, here's the control. here with this program. This is a very simple program, actually, to grind the tip of this insert. I just need two what they call forms. Let's start off by looking at that geometry here. The first form, I'm going to click on it, is the shape of the profile of the tip of the insert. So that's pretty simple and obvious. And then the other form, form B, we call it here, it's just the back cutting clearance on the insert. Now this looks a little bit strange because it's viewing the tool, I don't know, this is kind of hard to explain. The tip of the tool is this way to the left side of the screen, and the insert would be setting, I don't know if you can see this or not, but the insert would be setting kind of like this. And so this is the front, which the probe just touched off, and this is the back. So this is the back clearance on the insert, and then just a movement out to get the grinding wheel away. So when you're looking at this screen, this is the tip of the tool on this side of the screen. It's kind of reversed from in the actual machine, so it's a little bit confusing in a way. I don't know, they could have probably reversed that in the software. So if we look at this again, the tip of the insert, this is the side that the probe just probed on the actual tool. Okay, so those are the two profiles. And then the actual geometry you can set, I should go back to this, the relief angles here for relief form A, which was the tip of the insert. I've already programmed all this, so I'm not going to go through it all again, and this is the relief angles for the back side, if you will. And this controls the width of the tool. If you remember on the drawing, that was 145 thousandths width of this tool. The insert itself is 3/16 or 185 thousandths right now. So those are the two forms that we're going to grind. And the helix angle, see, this is where you would define that we're only grinding a single flute tool, and it's just a straight flute. And this stuff you can define for rotary tools, like irregular pitch of the flutes and a regular pitch and the helix angles. You can define all this stuff here for that. And this is the probing cycle, which is just the standard cycle really is all I'm using here. So there's no tip on this tool, so there's no definition for that. The blank, I modeled the holder, if you will, or the shank I made, and I've defined that in a STL file is what this machine likes to use for the simulation. So let's kind of look at the simulation here, just so you get an idea of what's happening. See, this is I don't know if you can see that. Maybe you can see it in the video. That's my modeled shank, and the insert is also in blue here. You can see it there. Let's just step this up to the tool. So it shows the shank vertical like that, just the way the simulation starts, because the first flute of an end mill, if you will, like let's say we're looking at this end mill, the first flute is always this flute, the vertical direction. So that's why the simulation positions it vertically. But then it rotates it around where it will do that when it probes it. When it finishes the program, it'll actually rotate that up vertical, you'll see. So I'm just going to step through this real slowly with a step key here. So let's see if I can position this so we can kind of see it. Now this isn't going to be totally lined up perfectly because I have offset it in the program to where it actually will grind it. So it looks a little bit off center on the insert, but that was necessary. Well, it does right now, of course, because it hasn't ground the width. Let's Let me step through the width of it here. So this is where it's going to be grinding the actual width of the tool. See, that's that angle. I don't know if you can see it here very good. That's the angle. And then the movement to get it away from the tip of the tool before it moves out and away, like that. So very simple, actually very simple program. And see, it'll move it back up vertical. Now, like I'm saying, you can, this looks like it's not centered properly, but that's what I found was necessary when I first ran this, the first time I did this job, to offset the profiles to get it centered properly from where it probed it. You know, there might be a slight inaccuracy in the way that wheel is positioning, I'm not sure. Oftentimes when you grind stuff, this is necessary. In fact, we'll go back here to this Form A. You see down here, there's an offset. You can offset it axially, which is in the length direction, and radial offset this direction, which I have no offset apparently on it for that part. And then this, I've actually offset this 8.8 thousandths. The other one was 9 thousandths, so this is about 2 10,000ths difference for where it should be. But I'm going to actually intentionally offset this, say a little bit more, because I want to bring that insert in on the width. And so I haven't set this up yet, so I'm gonna offset this about, let's say 15 thousandths. So I'm sure I'm going to grind it too wide. I'm not too concerned with the diameter because I'm just going to make all these inserts the same, and this is usually pretty close on this machine as far as that goes, so I'm not going to worry too much about that. This particular grinding wheel is using offset number 3, it says here. Compensation, offset number 3. And so I'm going to go back to Numroto here, control, and I've opened the offset pages, and I've got 0 offset on number 3. Now, oddly enough, a positive offset goes smaller and a negative offset goes bigger. So I'm gonna offset this minus 5 thousandths on the grinding wheel, just to stand off a little bit. I'm not sure why that's reversed. You would think that taking off the diameter of the wheel would make it cut deeper, but it's opposite on this. That's just the way this grinder is. I'm not really sure why that is. It's somehow how the software works. Oh, I could go back over here. You notice that I have the feed rate set down to 0 here. So that's why we're getting, and I've got the coolant turned off. If I turn on both of those, see those error messages go away right now. This it's important to have the coolant turned off in this when you have the door open, because you don't want to get all showered with that. It's got a lot of volume in this coolant system, and you'd get covered in oil, and that oil is not the nicest stuff in the world to get on you. In fact, for me, I'm a little bit allergic to it, and it makes me break out, kind of like poison ivy almost. So I got to be careful with this oil. So what are we going to do? We're going to grind the tool with those settings and see what we've got. So I'm going to go back over here to manufacturing, and I'm going to use the previously probed values. I'm not going to change them now for the rest of these inserts. I'm going to grind everything like that. That's kind of like it probed the offset. We'll call it the G54. I'm not sure if that's the way this machine sees it, but the G54 offset, we'll call it, and we're not going to change that now. It's set for the rest of this job. Okay. You can see why I can't really put the camera in there. Just being a little conservative with this. I'm backing down the feed rate some. Don't want to get too carried away here with things. You really can't see anything that's happening in there for the most part. Okay, that was the tip of the insert. Now I'm going to reposition the grinding wheel to do the back side. Kind of got a problem with this control, and I've got to sort it out. That's why I don't know if I'll show down here. I've got these springs holding the cycle start buttons down. It has 2 cycle start buttons. You got to push both of these to start the control. But there's something, I don't know, there's a pressure switch, I think, that's malfunctioning on the hydraulic system that senses the spindle clamp function. And it's not losing clamping force on the tool because I've checked that, but I think there's a pressure switch, and every time it checks it, if I don't have these buttons depressed continuously, it stops the spindle from running, which doesn't really cause a problem, but it just it stops the whole grinding process in the middle of it. And so I have to I have found just by trial and error or accident that if I hold the buttons down, it'll run through this whole cycle and it won't have a problem. So let's see, this thing repeats pretty good, so I'm going to take the insert out so I don't have to lean in here and look at it. We're going to see where we're at. Now, I don't know if you can see this or not. Let's see. I'll just try to show you. I'm going to measure the width of this. Okay, the width of it's 152 thousandths. Almost exactly. So I want 143 on the width. So that would be 0.152 minus 0.143. It's 9 thousandths. And I've got to change that offset by 9 thousandths on there. Now I'm looking at this. I know you can't really see it very well, but I have to make sure that this is kind of in the right place in the depth or the Z direction, if you will. It looks pretty well centered. Actually, this is like the drawing's calling it like 3 thousandths off center for some weird reason. I'm not really sure, although the tolerance is plus or minus 5, so it could be centered. It's 76 thousandths from, I'm not really sure how they're holding this insert and which direction that is on the groove, so it would probably be better just to make it centered because it'll be in tolerance if it's centered. So I'll have to look at this on the optical comparator and make sure that what I'm doing is centered. Also based on this 152 thousandths width right now, which means that it should be, of course, 9 thousandths wider on the back side here, if you will, if that's the side we're worrying about. I don't know if you can see that. This camera, of course, the 360 camera, it's kind of hard to show detail because you are filming in 5.7K, like it said, but you're only using a small section of the 5.7K with this kind of camera, so kind of hard to show things close up. It looks like I have to move out towards the front with that profile. I intentionally offset it out so you can see it hasn't quite cleaned up the tip of the insert, and I'm trying to not waste one of these insert tips. I'm trying to make it correct. So let me go over to the comparator and see what we're doing here. All right, it's incredibly difficult to film something on the comparator because of the bright light coming through the screen and everything. I'm just going to check, kind of focused on this So let's go back to the machine and we'll grind this tip of this insert over. And what was the width of the insert was, what did I say, 9 thousandths too wide? Yeah, it's 152, so it's 9 thousandths too wide. So let's re-offset that. I'll go back to the control and the machine and re-offset that, and then we'll see where we're at after that. So we're going to go back to our program, and we're going to, where did I offset those? So in the forms. So this, if I'm reading all this right, has to be 0.003, no, 0.0003 10 thousandths. I read that correctly. And this was 9 thousandths too far in. Remember, we got plus or minus 3 on this, but so we're going to go 0.015 minus 0.009, 6 thousandths on that offset. And we're going to grind this again, and we're going to take the 5 thousandths off our wheel compensation too. Okay, and go back to the control, and we're going to go to 0 on the number 3's offset here. So let me put the insert back in there. The appropriate end we're grinding. We're going to grind this again. First, we have to go back to manufacturing and reprocess the program. I'm not going to change the probing values, of course. We'll see how good that works, like that. So this is what you have to do. You have to kind of work your way up to it. It's not quite as simple as just probing it and pushing the button and letting it go. Grinding's like this every time you set up a new job. A lot of times you have to set up a test part. You know, particularly if you're grinding a complex tool, you're pretty much gonna waste you know, if you're grinding tools that have steps in them and chamfers, you know, like this kind of a tool, you're pretty much gonna like waste a blank almost, or you're gonna have these blanks you ground test tools on. It's just the way it is. This one, like you see, I've ground a couple of test pieces here. I don't think this was a double-ended tool that was that short for this kind of a form tool. Maybe it was, I can't remember now. Well, I've got a lot of tools over here I've ground in the past that, you know, like a tool like this. Somebody went up, it was to size a bore and go up in there and put a kind of a angled face groove up inside of a hole. Okay, so the grinding is done here. Now let me go here and measure the width of it here and see. I'm going to rotate. I'm going to go in the manual and rotate my. This is the A axis on this machine. Normally that would be a C axis on most machines. Okay, 142.65. Wait a minute. 42.7, 42.65. So I went a little bit far. It's still in tolerance, all right. Try to get these inserts all the same. I'm going to look at the tip of this, but I'm going to take it out of here. I don't want to lean into this machine and get this oil on myself. I say I'm kind of allergic to this oil, and it makes me break out. I'll look at this with a magnifying deal. I don't know if I cleaned up all the way to the tip of that tool. Just barely. Might take it a little bit further down. I'm going to check the centering on this. I'm not going to show you that again because I can't really film it on that comparator very well. Maybe I could with the proper filters on a camera, but with this 360 camera, I can't really do that very well. And then we're going to come back and I might offset that grinding wheel in just a hair more. I'm going to, what was the width of this? Again, it was about a 1/2,000. Maybe about 1/2,000 too narrow. It's not really out of tolerance, but I think I'm going to go back here and I'm going to set that in. I'm going to go to the Form B and set it in 0.0065. Okay. Just to get it right in the middle of the tolerance. Okay, I'm going to go over there and check these things on the comparator, and then we'll be back. All right, I'm pretty happy with the centering of that. Looks pretty good. The width, I'm not going to grind the width again on this particular insert, but I'm going to grind the tip of that just a hair more because it's like almost not cleaning up. I mean, I could probably leave this alone, but I want to make sure I take enough off these. That insert's in tolerance, but it's just a little bit out. Number 3, we're going to take 0.001. Well, actually, yeah, 1/1000th of an inch more on the end of that. I'm only going to grind that form, so I'm just going to select that and do that by itself. Whatever you select here, it'll do only that when it grinds. So you can unselect these certain parts of the tool and only grind that. So let's go ahead and do that. Make sure and clean up the end of that. And I'll grind the next point and check it for the width to make sure I centered it better. I mean, not centered it, but got the width to the 143 thousandths. I'm not exactly sure which way they're facing this tool or which way this groove faces on the part for the dimensioning. So I'm just going to center that point on the insert. It's in tolerance, and I don't think it'll be a problem. Okay, so that's that. Let's see if that cleaned up the tip better on this particular one, because that's what I want to make sure I do. Okay, clean the tip up all the way. I don't think that was enough to change the width of this insert significantly, but let's just see. No, not really. So I'm going to leave that. I'm going to leave that offset alone. Now we're going to grind one for real here. Let's index it to the next tip of this insert. And I'm going to go back to the software and select both cycles and then reprocess the program, if you will. See, this is like a CAM software in the computer that sends it to the control. So there's a control in the back of this machine, which is actually this Numroto control, which is this is the interface for it. And it controls the machine, and this other thing, the Numroto software, Numroto Plus they call it here, is a software that you make your program in, and then when you're doing that manufacturing selection, you're actually it's calculating and sending all the data to the control. And the control, this page is the control, and this is the machine position and everything. So we're going to run this. And if this looks good, then we can just run through each one of them. And that's kind of all there is to this. It's just a matter of running each one. Now you notice here, this you don't see any kind of G code or anything scrolling by. This is like a G997, and whatever that is what this machine is running. And this machine, this software posts out these, I guess it has these cycles, kind of like on a machine you would have drilling cycles and tapping cycles and whatever, or on a lathe you might have, turning cycles and everything. And this does it. See, you see a few commands coming back here when it rapided back to the clearance position to rotate the B axis. And these are just the positional moves, but then when it's actually doing the grinding, it's doing like a can cycle, if you will. And everything is in that. I guess you're setting variables to that cycle when you do your programming, and that's all you see running here on the the display of the program. So, assuming everything's all right with this, it's almost done. It only takes, here the cycle time, maybe about a little less than 2 minutes. Almost exactly, minute 58 seconds to grind it. Let's see what it looks like. Looks pretty good there, just looking at it. Let's see what the width is. I could set it in a little bit more in the Z offset. I'm going to go over here, go to Form B, and I'm going to set this into we're going to go 0.00689. I'm going to set it in a, okay, that much. Now whenever you make a change there, you got to reprocess the program, because I'm not using an offset on the grinding wheel to do this. I'm offsetting the actual program there. If I was using an offset like a fixture offset or the grinding wheel offset, I wouldn't have to reprocess that program. Okay. We're gonna do this one more time and see. We got a little bit closer on the width. It was only off a couple of 2 or 3 tenths. So I'm going to mark that insert as my setup insert in case they don't want to use it for some reason. Once I get this really sorted out, but it's still in tolerance. When I get this really dialed in, maybe I'll get the GoPro camera and set it in there, and run one not dry. I won't grind it dry, but I can rerun it after it's ground, and you can see what's happening in there. You really can't see. I mean, I can't even see standing here what's happening. You have to almost trust that things are going correct in there. I mean, you know, I can turn the coolant off, but you chance damaging the wheel if you're taking a heavy cut with no coolant on it. These aren't your typical grinding wheels. Let me, like most grinding that's done on manual tool and cutter grinders is done with a different kind of wheel than this. This is a totally different kind of wheel. These wheels are this is a cup wheel, brand new one. It's never been used. And these wheels have a different kind of bond. It's very hard for CNC tool and cutter grinding. The normal manual tool and cutter grinder, you use like a resinoid bonded wheel, and it looks kind of brown looking. But you can see, I don't know if you can see that here, but that's like, well, these look pretty much silver. This is a 3M wheel in here I've got, and it looks kind of copper color. I don't know if that's a coloring they put in their bonding, or if it's some kind of thing that has to do with maybe copper material in the bond. I don't know. I'm not sure about that, but these wheels, this particular wheel, I like this particular kind of wheel, which is made by Winterthur. I'm not sure how to pronounce that. It's German company, I think, or Swiss or German or something, but the Naxo Force. And I really like these wheels. These wheels work good. That's what this wheel is here. These wheels are a little bit expensive, not that bad. A CBN wheel is actually more expensive than a diamond wheel. You grind carbide with diamond and high-speed steel with CBN. This wheel here is a typical wheel like you might use on a tool and cutter, manual tool and cutter grinder, if you will. I've marked this as CBN. This is a CBN wheel here. But the diamond and CBN wheels look almost identical. It's just a different grit in them. And CBN wheels are actually more expensive than diamond wheels are. You wouldn't think so, but see this, let me see. Trying to see what grit this is here. Not sure. This might be also a CBN wheel. I don't remember for sure. But this is more like you would use on a manual tool and cutter grinder. And you see how the brown, you see how it's kind of soft even. I can almost scratch it with my fingernail. These are quite a bit softer. You really wouldn't use this kind of wheel in this kind of grinding machine. You could, but normally you wouldn't. So this is a typical wheel pack for grinding an end mill, like a carbide end mill. So this would be the fluting wheel. This would be the gashing wheel, which is what I'm using there basically, a gashing wheel, smaller in diameter than this one. And this would be the wheel that you grind, the cup wheel, you grind the cutting edges of the tool, clearance angles and stuff. So if we were to look at an end mill, you'd be fluting like this, if you can see that, and then you'd be gashing here like this. I don't know if you can see this or not. And then you would be grinding the clearance on the OD, and the face you would come in at a different angle like this. And you'd be grinding the face, the tip of the tool like that. So this here is a typical wheel pack to grind solid carbide end mills complete. You got all your wheels on here on one arbor. That's the way you typically do it on a machine like this. I'm just doing a very simple grinding operation here, which just requires one wheel. But this is the normal thing you use if you're manufacturing end mills from a solid blank. Let's take this out and see if we did any good with the width on here. Remember which tip it is. All right. Okay. I got that width just where I want it. Right at 143, maybe 50 million, or whatever that is. 0.14305. That's good enough. That's close enough on the width. So I'm thinking that's good. So now I'm going to mark that insert as my setup insert, even though it's in tolerance, just so they'll know, the guys here that are using these, they'll put Sharpie marks on it on both faces. And now I just got to grind all the rest of them. Just a matter of cycling through these things and grinding them now. And that's all there is to it on this kind of a grinding job.